All right, we're going to talk about Standard Level, Chapter 8, Section D, Chi-square Goodness of Fit Test. Okay, so before we get started, I want to define something, uniform distribution. That's when all the expected values should be the same. Okay, expected values, we would use F subscript E as we've talked about earlier. Okay, so let's look at an example. Okay, so Jiang wonders if her die was fair. She rolls the die 300 times with the following results. So getting a 1, 2, 3, 4, 5, 6. And here are the results she got when she rolled the die. Okay, so my first question is, what is the probability of getting a 1? Okay, so if you've got 6 possibilities, you've got a 1/6 chance of getting a 1. That should make sense, right? Okay, so the next question is, what is the, if you roll the die 300 times, what is the expected number of times that you would get a 1? Well, if I'm rolling it 300 times, 300 times 1/6, I expect to get a 1 50 times. I expect to get all of these 50 times. Okay, so if we're rolling a die, if we expect the same value for every single one, that is called a uniform distribution. Okay, we're expecting the same value every time. Okay, so our null hypothesis is going to be that Jiang's die satisfies a uniform distribution. So that's going to be our null hypothesis whenever we're doing a goodness of fit test. The alternative hypothesis is that Jiang's die does not satisfy a uniform distribution. Okay, and then the other thing is we find degrees of freedom a little differently. The degrees of freedom, they use the letter V for some reason, and it's equal to the number of rows we have minus 1. So here we have 6 rows, so our n value is going to be 6, and so our degrees of freedom will be 5. Okay. Okay, so like I said, n is going to be 6, so our degrees of freedom are going to be 5. Okay, so they might ask you, given a critical value at a 5%, what is the critical value at a 5% significance level? So if we know the degrees of freedom is 5, and we've got a 5% significant level, our critical value is going to be 11.07. Now in the Oxford textbook, for every single question, they give you the critical value at the particular percentage. Like I said, this would be useful to have this table if you're going to do your IA in this type of a topic. Okay, use your calculator to find chi-squared and p-values. Okay, so the first thing I'm going to do is we're going to be using this data here. Okay, so I'm going to press stat. Okay, so I'm going to show the calculator steps so you can see what I'm doing. So I'm going to press stat, and then I'm going to hit edit, and I need to put the information in. So I have to go arrow up to here. I'm going to hit clear and enter. Do not hit delete, it deletes the column. Okay, I'm going to go up here and hit clear and enter. Like I said, do not hit delete because that deletes the whole L1. Okay, so now I'm going to enter the stuff that we had here. So we have 35, 52, 47, 71, 62, and 33. Okay, and then L2 is what our expected value is going to be, and we said the expected value is going to be 50. So I need to put in here, I just have to write 50 each time. Okay, so now I've got 50 each time, and this column is the same as the original problem. Okay, second mode to quit. All right, and then now I'm going to hit Stat, arrow over to Tests, and I could arrow down until we get to chi-squared GOF test. GOF stands for goodness of fit. Okay, and then I hit enter. So we've entered this data in L1 and L2, so hit enter and enter. For here, DF, I need to make sure that I've got 5. Okay, so I hit enter. It's not always going to be 5 on your homework, so be careful. And I hit calculate, and then I get, I'm going to get 22.24, and I get a p-value 4.713, e to the negative 4. Okay, this is important because I always, every year, have IB students get this wrong. When you see this e to the negative 4, that means we go to the decimal place we have to go move the decimal place 4 places. So if I'm moving the decimal place 4 places, I'm going to go 0004713, right? Because if this moved 4 places, it would be 1, 2, 3, 4, and the decimal would have been there, which is what we saw. So if I'm moving the decimal 4 places, it goes 1, 2, 3, 4 to right here. Okay, make sure you understand that because every year I get IB students missing this, and I don't want that to happen to you guys. Okay, so now we've got our p-value, we've got our chi-squared value, so we can compare it to what we did in the previous notes, and so because 22.24 is greater than our critical value from the table, 11.07, we know that the chi-squared calculated is greater than the critical value, so we need to reject the null hypothesis. Now, I can find the same thing with my p-value. My p-value is 0.000471, which is less than 0.05, so this says we reject the null hypothesis also. So, in conclusion, Jayang's die does not satisfy uniform distribution because it fails both the chi-squared goodness test and the p-test. Don't forget your reason, because they're going to ask for, does it satisfy it, yes or no, and what is the reason? And the reason requires this last bit. I hope that helps you with your homework, and just look at this again, hit pause, and there is also a handout you can download which looks like this, which I recommend printing these instructions. It's a similar type of question, and it'll get it to do the same sort of thing. So hope that helps.